Today's brief lesson is an extension of separating mixtures that we did for the last unit, Unit 7. We are going to be separating different types of mixtures uh, that have two or more things dissolved in them, which is a little bit different than what we did with the sand to salt iron separation. So today's lesson is an introduction to separating solutions like that. So the first thing we need to do is go back in time and review what solutions are. And solutions are essentially two components that combine to make one thing in the single phase. The first component is the solvent. The solvent is the liquid or the thing that does the dissolving. Think water, think oil, think rubbing alcohol, for example. Those types of solutions dissolve stuff. The next vocabulary term or part of a solution is the solute. The solute is the solid or the substance that's going to get dissolved. It could be things like table salt, it could be sugar, it could be a gas like carbon dioxide, it could be other substances as well, but it's the thing that's going to get dissolved. So when you have those things, solvent and solute, in combination with one another, they create what's called a solution. And the solution is the combination of solute and solvent in a single phase. When I say single phase, I mean they're both in, like, say, the aqueous phase, or they're both liquids, or maybe they're both solids. But the issue is that they are definitely in the same phase. Which brings me up to an important thing to think, or an important part of solution formation is what we call like dissolves like. This is a rule in chemistry that is kind of like an unwritten rule, but it's really descriptive of what will get dissolved when. But to understand that, we need to understand a little bit about different types of molecules or substances. One of those molecules is called a polar molecule. We touched on the polar molecule a little bit earlier this year, but we definitely touched on it last year in biology. Water is a really common polar molecule, and so this image right down here is a water molecule. It has a slightly negative end and a slightly positive end. The slightly negative end will attract to a slightly positive something else. That could be more water molecules, it could be other charged particles. So those are polar substances. Then we have nonpolar substances. So these are things that don't have a slightly charged, slightly negative side or a slightly positive side. These are substances that are essentially considered neutral. And these substances that are essentially considered neutral will be attracted to each other, but not because they're positive. They have a positive and a negative side. So here I have something like carbon dioxide, where there is no charge distribution anywhere in this molecule. It's just considered to be neutral. Now in your notes, you have this sheet right here, and this is the slide we just were on, and then it goes to this slide, which is the slide that is next. But I forgot this slide right here that you're looking at right now. And what I would like you to do is take your packet, open it up, and in this blank space right here on the second page, or on the back side of the first page, I want you to add this. So like dissolves like really leads us to the path of things that are polar, like polar solvents, will dissolve things that are polar, like polar solutes. So water is polar, so water would dissolve things like table salt, which is polar. Sugar also is polar, so water will dissolve those things. Nonpolar solvents can only dissolve nonpolar solutes. So things like rubbing alcohol can dissolve Sharpie ink because both of those substances are nonpolar. But water, which is polar, does not do a really good job of dissolving Sharpie ink, which is nonpolar. So that's the next part of this, which is that polar solvents will not dissolve nonpolar solvents. So polar things will dissolve each other, nonpolar things will dissolve each other, but polar things cannot dissolve nonpolar things, and vice versa. So now we need to go back to this slide or this part of your notes. And we're going to talk about the idea of something being miscible or immiscible. A miscible solution is one that when two liquids mix together, they form a homogeneous solution. So here I have a yellow solution and I have a blue solution, and when they mix together, they form a green solution, a homogeneous mixture. There's really no way to tell that the yellow solution and the blue solution are even in there because you have something different. So this would be an example of like taking, if you've ever been to McDonald's or wherever where they have these soda machines where you can like choose your own soda, and you go and you mix all of the flavors at the same time. That's an example of liquids mixing together and being miscible. You are mixing all of the liquids together at the same time, and it's creating one delicious or horrible tasting homogeneous mixture. Immiscible solutions, or mixtures really, are when you mix two liquids together and they form a heterogeneous mixture. So here I have solution that is yellow, solution that is blue, and when I mix them together, I get two layered solutions where the yellow is sitting on top of the blue. This is like when you have, like if you've ever been at the gas station after it rains and there is the rainbowy film on top of the puddles. That's automobile oil or gasoline, and it doesn't mix with water, so it's sitting on top. Another example would be salad dressing that you have to shake, like salad dressing like vinegar and oil type salad dressing or a vinaigrette. If you shake them together, they kind of mix together, but if you leave them apart or let those the salad dressings sit for a little while, they separate into distinct layers. So that's immiscible. Miscible, they mix together, and you can't tell that there's two different liquids, two or more liquids there. Immiscible is when you mix them together and they settle out and they form distinct layers. Which brings me up to the idea of chromatography. Chromatography is used to separate two or more dissolved substances within a solution. So in our lab, you got to the point where you had to separate salt from water, and you just boiled the water out, and you were left with salt. So that would work really, really well for one thing dissolved in a solution. Now we're talking about more than one thing being dissolved in a solution, and one of the ways that we can separate those substances that are dissolved in solution is a laboratory technique called chromatography. Chromatography, there's many different types of chromatography, but the one that we're going to focus on is relatively simple. But all types of chromatography have three distinct parts to them. They have the analyte. The analyte is the substance that's being separated. So it's the substance it's the mixture that has two or more dissolved things inside of it. We also have the mobile phase. This is the part that moves with the sample, and it could be a gas or it could be a liquid. So what's really happening during chromatography is that we take our analyte and we have it move across an object, and that when it's moving across an object, that's called its mobile phase. And then lastly, we have the stationary phase, and the stationary phase is the part of the chromatography technique that does not move with the sample. And so in the type of chromatography that we're going to focus on, it is going to focus on a stationary phase, which will be paper-based, and a mobile phase, which will be a solution of two or more dissolved substances. So that's the lesson for today. And now we need to take a brief moment to talk about your homework for a moment. So this is what your homework is going to look like for today. The first question is asking you to use some of the vocabulary from the notes that we just took to fill in these three blanks. And hopefully that isn't too difficult. The next part of it is you are going to be analyzing a chromatogram, which is essentially the result of doing some type of chromatography. So in this diagram, what we're looking at here is we have our sample mixture at the bottom. It's a mixture of two or more sugars, so that's this part right here. And then we have our samples of actual sugars here, like sugar 1, sugar 2, sugar 3, and sugar 4. So what we did is or what a student did, or what this lab was they took their sugar sample that they knew had 2 sugars in it, and they performed a chromatography lab technique on it. And the results were a mark here and a mark here. Then the student went and compared the marks of the original mixture with the marks of the possible sugars that could be in that mixture. And in this case right here, we could say that the sugars that were contained in this mixture are probably sugar 4, because these 2 marks are at the same height or almost the same height. And then for the other sugar, we could probably say that it's sugar 2, because these marks kind of line up. So you're going to be analyzing some chromatographs and identifying what is in the substance, or what was in the original mixture. And that's what you're going to be doing today for your homework, and it really shouldn't take very long, so you should be able to finish that.